All right. So today I'm going to be demonstrating some of the new features that we've added for profiling recently, including some CLI functionality. So the way you enable this is this task diagnostics option. Previously, this was a Boolean true false, but now it is a list. And there's a list of possible values and some explanations. And you can enable these various diagnostics. There are some caveats for some of them. Some of them have more performance overhead than others. And one thing I noticed is that the pyinstrument one and the memray one kind of interfere with each other a bit. So it's usually best to have not all of them enabled at the same time. But this is how you enable them. And you don't have to enable them all at the same time now. All right. And so I've already run some syncs and publishes, some tasks. So those already exist. So what I'm going to show you is the feature that Matthias, well, to start with, I'm going to show you the feature that Matthias added to simplify fetching profile artifacts from Pulp. So Pulp task profile artifact URLs. So it's Pulp task profile artifact URLs UID. Instrument. Whoops. Not that. Copy this UID. Dang. Okay. My copy and paste isn't working properly from this. Maybe it's
try either right click copy if it brings up a menu, or middle button paste, one of the two.
This was working earlier.
Of course it was.
I've angered the demo gods. Okay.
Exactly right.
So
you want somebody to read it out by hand?
No, I
0197. There you
this
go.
a couple of times. So here we go. So you can pass href or UID, and there is a download flag. And what the download flag does is it goes ahead and downloads all of the URLs for you and dumps them into a handy directory. And so you can see here that it's created this directory with the name of the task, the type of task, and the UID basically, and task. You can see that our pyinstrument profile is there. So I'm going to open that. This is an HTML file, and what it shows you is this. Usually, it is more readable if you like crush some of these. I'm not sure if you can auto crush some of it. But you can see that it shows you the amount of time spent in various functions. And one thing that I normally do is I switch it to percentage by default. So by default it tells you the number of seconds spent and inside of each function. And usually I find percentage much more useful. I'm not sure why it defaults to time versus percentage, but it does. And so one thing, just looking at this, that's interesting is that we're spending 6% of our time in DonnyConf. So that's something I noticed right away, like as I was preparing this, is, hey, Probably, if some enterprising person wants to take a look at why we're spending 6% of our time during a published task in Dynaconf, that's straight away, that's a very interesting opportunity. And that's why I really like these profiling tools. They do show you opportunities like this, pretty clearly. Sometimes you have to dig a little bit harder, but in this case, you don't even have to dig that hard. Otherwise, there is not a whole lot here that was obvious. However, there's one more feature here that I want to show, which is you can switch from call stack view to timeline view. And so I will do that. Now, this is very interesting because you can see what it's doing over time and where it's spending its time over time. One of the things that you notice here, the Dynaconf stuff shows up too here. So this is what a lot of these little tiny green lines are. It's Dynaconf. Something in Dynaconf is being called many, 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 many times, and it's adding up. And you can see that how the task is spending its time over time changes. And it's this is extremely useful. One other thing that I thought was interesting is that let me see. There's many, 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 many calls to this package.refresh from DB and deferred attribute.get. This suggests maybe there's an n1 problem or n+1 problem somewhere that we're looking up, doing individual lookups on each field or something along those lines. Because there's many, 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 many different calls to this. All right. And there's other view options here as well. You can exclude frames. You can include and exclude import lib. Obviously it's hiding itself by instrument. And there's different options here. So you guys can play with this on your own time. My point is just, this is very useful for performance profiling. There's one more thing that I would like to show you, and this is something that I added recently, which is memray. So just one that ends in .40. There we go. Right. You can see that instead of a pyinstrument profile, there's a memray profile. And what memray does is it helps you debug memory allocations. So memray, so the first thing I'm going to show you is memray tree. Task profile 5, 3. There we go. And so the memray tree command gives you kind of this interactive UI inside of a terminal. But so where this is measured is at the point of peak RSS. So memray is tracking where all the allocations are over time, but it's only recording the snapshot that is at the time of peak RSS. And so when memray is using, when the task is using the most memory that is using through the entire runtime, that is when your snapshot is. And you can see there are multiple different ongoing publish tasks, which makes sense because there's subrepos and multiple different calls to generate repo metadata. And the memory, the most of the memory in this task is being used iterating over presumably the package query set. It's this iterator, and that makes total sense. And there's really not any low-hanging fruit to be seen here, because it's all coming from iterating over this query set. And you can see on the right-hand side here that it will give you literally the line in the code where the memory is being allocated. That is very useful, and really helps in terms of interpreting the results here. This, of course, makes sense because you're allocating memory in Python because you're dragging data out of the database. And that's another point to mention here, is that this is specifically Python memory. This doesn't include native frames. You can go into the code and edit the memray profiler constructor to turn on native allocation tracking, but it slows everything down. So that's not something that I enabled by default when I added this. All right. Yes, you can see just, it's where most of it's going. And so the last thing I'm going to show you is memray flame graph. There's actually a bunch of different sub utilities in memray that are very useful. But I find these are the two most useful. So if you want to learn about the others, you can look at the documentation or the PR where I added this. I added some screenshots and descriptions about what you can do. All right. So what this can do is it's going to write an HTML profile, which you then have to go and open like pyinstrument. And this shows you basically the same thing, but in a flame graph type display. And in this case, it's almost even more obvious that there's really not a whole lot of low-hanging fruit here, because the entire almost all of the allocations are coming from this iterator, basically. Iterator of the package query set. One last thing that's very useful is this memray timeline. So even though memray does not give you a measurement of detailed measurements of exactly where the allocations are coming from over time, it does measure, so one, the resident set size, and two, the Python heap size. So you can see, over time, not only, how much memory is my process using, but how much memory is Python using from that, of that total process resident set size. And it goes, there's a more detailed view here, which I'm not sure exactly what the resolution on this is. I think it's like 0.00 or 0.1 seconds or something. So this is much higher resolution than the resident set size calculation that we had previously that you can enable that's just a thread that checks every 5 seconds. So I find that, this is very, very useful, and it's pre-graphed for you, of course, and you can like zoom. So that's about all I have to show. You can invert it. There's an option for hiding import system frames, which doesn't really do anything on this particular chart. But yeah, that is it for my demo. Thank you.
Thank you so much, Daniel. We have one hand raised at least, and folks, if you have more questions, definitely ask. Brian?
Yep. So this looks really great. Is it, I think I saw, just confirming what I think I saw. So you can enable it in the settings file. You run operations in Pulp, and then you can use the CLI to fetch those assets and then use local tools to analyze it. Is that right?
Yep. And it's much easier than it used to be, because
yeah,
now,
it's way easier.
Thanks, especially to like Matthias's CLI edition.
Yeah.
Like it was a real pain to download those artifacts, and now it's not. So
Yep.
Thank you.
And so, yeah, I completely agree. Thank you. And so then is there some path to having this run on some operations and not others versus like in terms of like a system-wide, it seems like a system-wide setting. Is it right that it's system-wide? Like every task that runs, for example, will generate this?
It's correct that it's system-wide, yeah.
Do you think there is a path for future work to maybe make it optional? And
you mean like filtering what tasks it runs on, like run this on all published tasks, but not on the rest, something like that?
Yeah, something like that.
Yeah, you could add that, I think.
Cool. I'm not sure how it's like loaded, for example, but hey, listen, you answered my question, which was to level set what I think I saw. I love this work. I think it's super useful. Thanks a bunch.
And just to add a thing to the Brian's idea, like maybe run on a percentage of the tasks itself. Like I don't want to measure all tasks, but maybe like randomly, like choose one or another task to run, like the profiler, like 1% or even less, like number of tasks.
Yeah. I wonder if that would be valuable. Just because like you do have to then, know which ones it ran on and then go hunt those down specifically, because it's not gonna like it's not gonna like put those profiles somewhere automatically for you for analysis like OpenTelemetry does. So I feel like you would want to know which tasks it's running on. We definitely have to have some sort of discovery mechanism if we were to do something like that. But also just like, it does have some overhead. And so it's not something you'd want to enable in production unless you were doing it like temporarily for debugging. And you know exactly what it's running on. So yeah, so that's an interesting idea. I think filtering probably makes sense. I don't know about random selection.
Yes.
You're muted, Matthias.
I still can't hear you.
You can type your question up, maybe, or maybe he's AFK. I don't know. Any other questions while Matthias is figuring that out? Oh, do you think it would be worth calculating the HTML things in the worker too? No, I don't think so. Just because, for longer tasks, it can take a little bit of time. Also because, it's not something that memray has a way of pre-processing it for you in code, I think. So you have to run the executable. At the very least, there's no way that's stable API to do that. I'm sure there's a way to do it, but I don't think they're really meant to. Also, just you're not always gonna use every HTML page. So there's flame graph. Like I said, there's a bunch of different options. There's flame graph. There's table. There is there's what else? Flame graph, table. Summary, stats. But yeah, there's also a live. I've tried live. It doesn't work super well. But when it does work, it you can see a PySpy rundown of what the process is using, what in the process is using a lot of memory right now, and that's kind of useful. And there's also attach and detach. That's again like PySpy, you can attach it to already running executables, and collect during a certain time window. Yeah.
Okay, thank you.
All right, Daniel, thank you so much. Sorry, Matthias.
I just wanted to say I used the flame graph before to hunt down a very serious import performance issue. Nice demo. Thank you.